Today we're going to be looking at question 44 from the SAT number 17. This is the April 2019 QAS test. So question 14, 44, my mistake, 44. So question 44 says, based on passage 1, which hypothetical discovery would provide the most support for the impact hypothesis? So we're basically looking for some kind of discovery which would support the impact hypothesis. And if you've been following along, or if you just read through this text, you should at least have a okay or decent understanding what the impact hypothesis is and sort of what the main theories are. So we're going to just go through the answer choices and try to choose one that makes the most sense. But already, let's make sure that we have in our head sort of what the right guidelines would be, or something that we should expect. So the impact hypothesis is basically this idea that a meteor, or some comet, some asteroid basically exploded off the northern caps, and then that's what caused this cooling period called the Younger Dryas. And this happened 13,000 years ago. And they have all kinds of evidence for that. So anything that would support that claim is what we're going to be looking for. And this question here, we have to be careful because there's a lot of little details in it which will make an answer choice either right or wrong. So let's pay attention to the details. So A says an asteroid impact crater beneath the northern ice cap contains high levels of iridium and has been dated to well after the start of the Younger Dryas. So an asteroid impact, that's going to support our claim. It's beneath the northern ice cap, that's where the asteroid was supposed to land. That's going to support our claim. Contains high levels of iridium. That's another point that the passage makes, which high levels of iridium would come from outer space. However, this part here has been dated to well after the start of the Younger Dryas. Doesn't work for us because the impact hypothesis is that this comet, this asteroid, was what caused the Younger Dryas, the cooling period. So for this to occur after the start of it wouldn't make any sense, so we can get rid of A. Then we have B, which says glass and carbon spherules, which is something that they found in these little Clovis sites, which they're saying is evidence for an extraterrestrial impact. So this is so far good. They appear at multiple points in the geologic record. Fine, this is already supporting what we're saying, but never in conjunction with the iridium deposit. So let's think about that. Let's remember what they say about iridium. That's right here. It basically says that they found spherules of glass and carbon and amounts of the element iridium said to be too high to have originated on Earth. So in support of their claim in the passage, they're basically saying not only are we finding these glass and carbon spherules in these sites, but we're also finding iridium, which is there's too much of it to have originated on Earth. So B wouldn't really make too much sense if you just found these glass and carbon spherules, but you didn't find any iridium deposits. Based on what the text has already said to us about these two things, it seems unlikely that this would really support the hypothesis. Let's get rid of B. Then we have C, which says analysis of ice cores suggests that global temperatures started declining approximately 13,000 years before the onset of the Younger Dryas. Okay, so this is basically saying that the global temperature started going down 13,000 years before the onset of the Younger Dryas. But don't let this 13,000 years confuse you. We want to make sure we understand what's going on here. So basically the theory is that the impact was what 13,000 years ago is what caused the Younger Dryas. So it wouldn't make sense to say that things started being cool actually 13,000 years before the Younger Dryas, which happened 13,000 years ago. So basically 26,000 years ago, the Earth started cooling, because this is not going to support our claim, because the whole idea is that it was the asteroid or the meteor or whatever, the impact of that, which caused the cooling. So for this to happen 13,000 years before this happened, wouldn't support it. Let's get rid of C. Then we have D, which says high levels of osmium, which is rare on Earth. Okay, sort of like iridium. So far, so good. But relatively common in asteroids. So far, so good. Are observed in the geologic record. Great. From approximately 13,000 years ago. Perfect. Because 13,000 years ago is when the Younger Dryas, the cooling period, was supposed to start. This is when the asteroid or meteor is said to have landed and hit. If it has high levels of osmium, which is something you're not going to find on Earth, but you're going to find in the asteroids, then this is all good. And because this is our last answer choice, it matches up. Let's choose answer choice D as our correct answer for question 40.